Okay, good evening, everyone. Welcome to the Leitner Observatory Tuesday night public night live stream. I'm Michael Faison. I teach here at Yale in the astronomy department, and I'm the director of the Leitner Observatory and Planetarium, and I run Tuesday night public nights. Normally, we open up to the public and do planetarium shows and public observing with our telescopes. But with the observatory shut down to the public at the moment, I'm doing these Tuesday night live streams during the semester, talking about what's up in the sky this week and astronomy news, and happy to take your questions that you might have about astronomy. Feel free to type in questions or comments into the chat. Hi, Chris. Thanks for joining us. Type in your questions, and when I see them, I'm happy to take your questions. Here's a live view of the observing deck at the observatory. I'm at the observatory right now in the staff office, which is where I've been doing all my teaching and recording of videos and conferences and meetings and so forth. Not teaching from home. I'm fortunate that I get to come into campus to work because I'm literally the only person who works in this building right now. It's actually convenient because my wife works at home, so we get to get away from each other for a lot of the day. But it's nice that tonight it's relatively clear. I wouldn't say perfectly clear, but it's relatively clear. I was just outside looking at the sky with my owl eyes, my 2x54 binoculars, which basically funnel a lot of light into your eyes so that it's easier to see faint things. And this really helps with the light pollution I've discovered. I've got also my more normal binoculars. Can you tell the difference between these binoculars here, which are, 10x50 astronomy binoculars, right? And these binoculars here, which are kind of ridiculous 2x54. The first number is the magnification, and the second number is the aperture size. So these actually, in theory, gather more light than these because they have a bigger lens aperture. Anyway, I've got my binoculars ready, and a couple of times I've gone outside to check the sky and look at some of the constellations. You can see I have the 12-inch telescope set up on the right side of the observing deck over here. It's actually dark out on the observing deck right now. I have all the deck lights turned off, but you can see what's going on out there, and you see a little bit of haze, and every so often you see an insect fly by. Because there's infrared lights on near-infrared LEDs on this camera that I'm using that light up the scene a little bit. So if I were doing really sensitive work out there, taking long exposures of faint objects, I would turn off those infrared LEDs, and I certainly wouldn't point the telescope right at the camera, right at the LEDs or anything like that. But it does make it easier to see what's going on out on the observing deck when I'm controlling telescopes remotely. Maybe it's not too far away that it'll be warm enough I can go out and do a public observing session out on the observing deck as I was able to do last summer. I have some classes coming up where I'm doing some remote observing with classes, and I'm hoping it'll be warm enough that I can run things from the telescope outside. I also, you can see over here, I have a camera on a tripod, and I'm hoping later to take some images of some constellations. I was testing taking some, I think I see some stars up at the top of this image, probably Sirius and Canis Minor. I was taking some images of the constellation of Canis Major and Canis Minor and the area of the Milky Way kind of between them as sort of a test. This is not a fancy setup. I have a Canon digital SLR camera, just like a $200 SLR camera on a inexpensive star tracker on a tripod. And I've set that up out there so that I can take wide field images of constellations. And my goal actually later is to take some images of the asteroid Vesta. So Vesta is one of the largest asteroids in the asteroid belt. I think it's actually the third largest asteroid after Ceres and Pallas. And it's one of the brightest asteroids. And it is actually possible to see it with the naked eye if you know exactly where to look and you look at exactly the right time. And so this week, Vesta is especially close to the Earth and especially bright. It's orbiting between Mars and Jupiter. It's not a near-Earth asteroid. It's a main belt asteroid. And I want to show that you can track an asteroid and determine its orbit using images from just a camera, just from an SLR camera like that. So I'm going to try and take some images tonight from that tripod in about 2 hours or so. So we'll see how that goes. Now, at the moment, I have the 12-inch telescope pointed at the planet Mars. So let's see what it looks like. All right, let me switch over my computer to display to the computer which is controlling the 12-inch telescope that you can see in that DEC video camera. So this is showing me where the telescope is pointed, right there. And here you can see the planet Mars faded quite a lot compared to how it looked last October when it was close to us at opposition. There's that little star cluster called the Pleiades star cluster, also known as the Seven Sisters star cluster, also known as Subaru, right, which is a word that means unity, and that's the Japanese name for that little star pattern, that asterism. You can also see over here to the left, you can see the sort of V-shaped pattern in the face of Taurus, the bull. So here's the constellation of Taurus. The Pleiades is actually in the constellation of Taurus, and Mars tonight is in the constellation of Taurus. And there's another little star cluster right in there. And then if I look sort of down and to the left, I can see the constellation of Orion. So if it's clear where you are right now, if you're in New Haven right now, you should be able to go outside, look due south, look approximately 45 degrees up from the south horizon, and see the constellation of Orion right now. Those three bright belt stars are easy to see even when there's light pollution. And then you have the bright red star of Betelgeuse up here in the upper left, and the bright blue giant star Rigel down here by his foot. Okay, now quit stalling and show us Mars, is what you're saying. Okay, well, let's switch to the camera control and see what we see. Okay, here's a live view from the 12-inch telescope, and there's dinky little Mars currently as seen by the video camera that I have mounted on the 12-inch telescope. So it doesn't look great. It doesn't look terrible. It looks like there's a little bit of wind, and the atmosphere is not super steady tonight. When I was out looking at Sirius with my binoculars, the brightest star in the sky, I did notice there was quite a bit of twinkling. So this is a property that astronomers call seeing, right? S-E-E-I-N-G, and it's how steady are the stars when you're looking through the atmosphere. Is there a lot of turbulence that are making the stars twinkle and shimmer and so forth? And the stars are not super steady tonight. Now, they're never super steady from New Haven because we're in a city at sea level. This is one of the reasons why astronomers put their professional observatories on the top of high mountains, far from cities, near the ocean, so that the airflow is really steady. Or even better, put your telescope in space where you don't have to deal with this shimmery atmosphere, and then you're going to get the super sharp images that we get from Hubble Space Telescope. And up soon, the James Webb Telescope. I heard a rumor it's going to launch this year. We'll see. That would be exciting. But Mars, I think I can see some surface features here. Now, this is a situation where it really wouldn't help to have more magnification. You know, it wouldn't help us to have a more powerful telescope in this situation, just because the atmosphere is so blurry. You really can't see any finer detail. You know, sometimes Mars gets steady for a fraction of a second, and it can help actually to lower the exposure time a little bit, because then you can get for a fraction of a second, you can get a sharp image. But I don't want to oversaturate the image of Mars. Yeah, okay, I think I can see some dark regions right in there. So there are a couple of things I notice with this image. And again, by all means, feel free at any time to type a question in the chat or comment in the chat if you have a question for me. But something I noticed is, number one, it's a lot smaller than it was in October when it was close to the Earth. So back then, it was at a distance of about, let's see, I think it got it as close as 30 million miles approximately. And now it's at a distance of about 90 or almost 100 million miles. So it's 3 times further away, which means it looks 3 times smaller through a telescope. So it's quite tiny. The other thing is that I notice it's not fully illuminated. right? So the planets will also go through phases, just like the moon does, depending on how we see it as an angle to the sun. So we see the full moon when it's opposite the sun, and we just passed full moon last Friday. So we have a gibbous moon, a waning gibbous moon tonight. So you'd have to stay up past sunset, past probably about 10 o'clock in order to see the waning gibbous moon rising. The moon, Mars right now, when we saw it opposite the sun, it looked fully illuminated. It looked like a disk. And I think I can see clearly that it's lit more on the right side than on the left side. So it's sort of a gibbous Mars, or a half Mars, if you like. And that makes sense because where it is in its orbit, the Earth has passed it by in its orbit. That happened last October. And now we're getting most of the way around our orbit away from Mars. And so we're seeing Mars at kind of in between, fully illuminated on the far side of us relative to the sun. And it's going to go back to fully illuminated when it's in line with the sun on the other type. So it's kind of intermediate between those two. Now, to kind of convince myself that I really am seeing the phase that I expect in this image, and that I am seeing some surface markings on Mars, which are challenging to see, but you can certainly see them at opposition. If you missed opposition last October, don't worry, every 2 years and 2 months, Mars swings by. Now, this past opposition was a little bit closer than average, but all of them look great. It really doesn't make a huge difference whether you see Mars at perihelion or not. So don't be disappointed if you missed it. You'll have another shot. Kind of like with the eclipse, right? If you saw the eclipse in 2017, you were lucky. If you missed it, you have the chance to see it April 8th, 2024. We have another American total solar eclipse coming up for us. So it's actually about time to start making your plans because traveling to where there's going to be a total solar eclipse, you have to make your reservations in advance as they book up. Anyway, let me switch over to my sky simulator, to Stellarium. So here is what Mars looks like right now. So if I zoom out a bit in the simulator, you can kind of see what's going on. And it is interesting that Mars is quite close to the Pleiades star cluster. There you can see it right there. It's not super bright right now. You kind of have to make sure you know where you're looking if you want to make sure you're identifying Mars. It was super bright, whitish red, orangish red last October. Now it's about the same brightness as the star Aldebaran over here in Taurus. Let's see, the brightness of Aldebaran is 0.85, and Mars right now is 0.94. So Aldebaran is just a hair brighter than Mars right now, whereas Mars last fall was the brightest thing in the sky in that direction. Anyway, let me zoom in again on Mars. We have to zoom in quite a lot. And yes, okay, so I see that it's mostly illuminated kind of on the right side. It's kind of a gibbous Mars. It's not, I wouldn't call it a half Mars or a quarter Mars like the moon, but it's clearly not fully illuminated. Now, I think I can see kind of a dark band in kind of the middle of Mars, and that's the dark area just north of Hellas Planitia, which is this impact basin that's kind of bright right in here. Now, the Perseverance rover landed right here in a river delta that's off a crater, which is right here on this part of Mars. So if we had a sensitive enough radio dish, satellite dish, if you like, radio telescope, we could maybe point at Mars and pick up some of the telemetry from Perseverance or any of the other, half dozen or so active spacecraft around Mars right now, including there's a spacecraft from UAE there now, and of course some of the other orbiters from NASA and ESA are there. You can just see the moon, one of the moons of Mars, Phobos, coming from behind Mars there in the simulation. And if I run time forward a little bit, let's see if I can do that. Let's switch over here to the simulator and run time forward a little bit. There we go. There you can see that moon of Phobos coming out from behind Mars, and there you can see Deimos over there. These are much too small to see in a small ground-based telescope. So even in our image here, let's go back to this image here. So here's live image from the 12-inch telescope of Mars. I think that's about the right phase, and I think I can see some dark markings kind of in the middle, but the twinkling of the atmosphere is tough tonight in terms of allowing us to see any surface features. Planet Noble says beehive cluster. Yeah, we could go look at the beehive cluster, or maybe we could look right at the Pleiades, which is right nearby. Or actually, I was thinking if you want to be a planet completist tonight and look at all of the planets that are visible above the horizon at the moment, the planet Uranus is right over here. And Uranus is not that exciting through a telescope. It's a little blue dot, but if you want to see a live view of Uranus right now, we could do that. And then the Pleiades is right up there, and then the Orion Nebula is also beautiful. And I don't think we've looked at the Orion Nebula during any of these live streams, because it was we started doing this kind of end of March. Actually, middle of April was when I started doing this last year. We closed end of March, and we started doing the live stream end of April. And then we were shut down during winter solstice. So let's see, why don't we go take a quick look at Uranus over there, and then maybe the Pleiades, and then maybe the Orion Nebula, and then we can go over and look at the beehive cluster as well. Planet Noble, if it's clear out there in Arizona, you're going to have much better views than us poor East Coasters in the city with terrible seeing. So I'm going to move the telescope over to Uranus first, and then I'll do a really quick talk about what's up in the sky, and then I think I'll just do some fun telescope pointing, observing for the rest of the session. So queue up your requests. So there's Uranus. I'm going to command the telescope to move over to that. And then here is the live view of the observing deck. So you can see the 12-inch telescope over on there on the right. It's sort of moving to the west, and it's moving down a little bit. Chris asks, what simulator is that? So I'm using a sky simulator here to just kind of see what's up in the sky, and I used it to just see what was the orientation and so forth of Mars. This is a simulator called Stellarium. And this one is great because it's free. It runs on all operating systems. You can download it from stellarium.org. I use this a lot for teaching. You can, in fact, use Stellarium to control telescopes or to run displays on planetariums. It's very sophisticated. But to actually control the telescope, I'm using different software. I'm using this software called the SkyX. And this just has some nice features for controlling our particular telescope mount and our cameras and our focuser. So everything's integrated nicely, and things can be automated and so forth. So this is what we use for our advanced lab projects at Yale and for some student research projects at Yale. Okay, let's see if we've got anything in the field of view of the camera. So Uranus is quite a bit fainter than Mars, so we'll have to increase the exposure time here. Oh, yeah, I see it right there. It's a little blue dot. Let's make it a little bit brighter. Now, Uranus is going to appear even smaller than Mars. Of course, Uranus in reality is much bigger than Mars, right? So Uranus is approximately, 4 or 5 times the diameter of the Earth, roughly. And Mars is about 3/5 the diameter of the Earth. So, so it's going to mean that Uranus is 8 or 9 times bigger than Mars. I think we need just a little bit longer exposure time here. All right, can you see that popping in, that little blue dot there? And there are a few other stars in the background as well. There it is. That is Uranus. And Uranus is always going to show a full phase because it's much further away from the sun than the Earth is. So from the point of view of Uranus, the Earth and the sun are right next to each other. So, we never see Uranus at some angle to the sun. Let's see, the distance from Uranus, the distance from Uranus to the sun is about 20 times the distance from the Earth to the sun. So Uranus is quite far out there. Uranus also is possibly visible sometimes to the naked eye when conditions are really favorable and Uranus is especially close to the Earth and the sky is really dark. In theory, you can see Uranus with the naked eye. Now, anything that can happen, anything that can be seen with the naked eye, of course, has been seen by the naked eye many times because, of course, humans have been looking at the sky, since we've been sentient, looking at the sky and noticing the star patterns and the phases of the moon and the motions of the planets and so forth. The thing is that Uranus is really only visible to the naked eye when it's closest to the Earth, right at opposition. So you're not necessarily going to notice a pattern of watching Uranus move relative to the background stars. Hence, Uranus wasn't discovered until the late 1700s. What was it, 1780 something? Discovered by William Herschel, the German/English astronomer who was interested in studying double stars and comets with his sister, Carolyn. A lot of the discoveries that he made now, he and his sister, Carolyn Herschel, get sort of credit for discovering. There's all sorts of interesting stories about Uranus. Uranus, when Herschel discovered Uranus, there's a little bit subtler view. There are actually 5 moons around Uranus, and if you take long enough exposures with a bigger telescope, you can see the moons, but I don't think this telescope is going to be big enough. I think maybe we'd have to take really, really long exposures to see those little tiny moons. Oh, maybe. I think I may be seeing moons. There, I see a little, I don't know if you can see this on the stream, but I see a little patch of light at around 12 o'clock and a little patch of light around 7 o'clock. And you know what? I am going to switch over to the simulator to see where the moons are supposed to be and see if that's what we're seeing. So I'll zoom in here and find Uranus. Okay, there it is. Yeah, that's where they're supposed to be. So I haven't done this in a long time. Years ago, when I used to teach at Mount Wilson Observatory, we would routinely find the moons of Uranus with a 16-inch telescope. So I haven't done this in a long time, so I'm really surprised. I'm really impressed that this little 12-inch telescope in the city can see some of the moons of Uranus. So this little smudge of light way up here is the moon Oberon, and then this little smudge of light down to the left is the moon Titania. You may notice a theme with the names of the moons of Uranus, right? Miranda, Ariel, Umbriel, right? These are the characters from A Midsummer's Night Dream. So if I go back to the live view from the telescope, I can certainly see Oberon and Titania, and I don't think I can see any moons right in there. So that's interesting. I kind of want to take some longer exposures now with the bigger telescope just to kind of see what's going on there. But it's actually, maybe I can see a little smudge of light. I'm going to try even longer exposures here, like maybe a 3 or 4 second exposure. I think I can maybe see a smudge of light right in here. There's a smudge of light right there, a smudge of light right there. I can see a little smudge of light right there. So that's really cool. Anyway, there's all sorts of interesting things, we could talk about with regards to Uranus. The discovery, famously, William Herschel, when it was discovered, wanted to name it after the King of England, so George III. And so he called it George's Star. And I like to imagine that it was just going to be called George. So here's Planet George. it would be in Latin, Georgium Sidereum or something like that, George's star. But a group of astronomers agreed, no, that's not a good name for a planet. Let's continue with the Roman gods. So, we've got Jupiter, Mars, Jupiter, Saturn. Saturn is the father of Jupiter, so the father of Saturn is Uranus. So we'll go with Uranus. Uranus is tilted edge on, or pole on, basically. So it has the most extreme seasons if it made any difference, the distance to the sun. And I think since we're seeing the moons kind of face on to the way we're looking right now, it must be either summer or winter solstice on that side. Yeah, Planet George. I think Planet George is great. And, then you don't have the sort of embarrassing name that astronomy teachers are always trying to avoid, right? Talking about seeing Uranus through a telescope, right? I've sort of trained myself to say Uranus. I'm not sure what the most teachers say, but George would avoid that problem. So maybe we should bring back George. I'm going to go back to the simulator and see what the angle is to the moon orbits. Okay, so so you're seeing kind of a bullseye there showing you the moon orbits. And so, yeah, I think the axis of Uranus would be there. And Uranus has rings. Uranus has 5 rings, which are in the same orbital plane as the moons. They're too dark to see in visible light, so you either have to look for them in infrared light or you have to see them when they block the light from a background star. So every so often, Uranus will sort of move through and occult or block the light from a background star. And you see the starlight blink out when it goes through the rings. That's how the rings were discovered, in fact. Okay, let's move to maybe the Pleiades. All right, so here's our last view of Uranus. And I'm going to ask the telescope to move up here to the Pleiades. Now, the Pleiades are fairly big in the sky. Right? They take up a lot of area of the sky, compared to other things you might see through a telescope. So we're not going to see the entire star cluster through the camera. All right, so there goes the telescope moving over to the Pleiades. And if we look again at the live view of the observing deck, you can see the telescope, the 12-inch telescope, shifting to the left and up a little bit to point at that target. Okay, so now we're on the Pleiades right there. Let's switch over to the live view here. Okay, I kind of want to save that image of Uranus. I think I'll go ahead and save that before. There we go. Okay, so let's see what we've got now through the telescope. I'm taking very long exposures here, so let's undo that. And actually, this might be the point when I should switch from the video mode on the camera to the longer exposure, or the stacking mode, where it will combine images to get a better image, to get less noise. Essentially taking a longer exposure by adding together multiple images. Just confirm that we're pointing at stars. Yeah, I see a few stars there. All right, so that's a 3-second exposure. I can see the time counting there. I can raise the amplification a little bit. Yeah, so that's part of the star cluster. I think I'm seeing kind of the middle of the star cluster where there are a couple of really bright bluish stars. We could zoom in on the star cluster and see what some of the names of the stars are. The Pleiades, the seven sisters, are the daughters of Atlas in Greek mythology. So you have Electra and Maya. Here, let's just look at them here. Chris is asking, what is the size of the bigger telescope? Is it possible to show a comparison between the one I'm using and the bigger telescope? I wonder if you mean by the bigger telescope the one that's in the dome, the 16-inch telescope dome, which is, if I said the bigger telescope, that's what I meant. So we have up here at the Leitner Observatory 2 permanently mounted telescopes in domes. And you can just see the edge of the west dome here at the edge of the camera frame. There's a 16-inch telescope in there, which means the mirror, 16 inches would be about that big. The mirror diameter is 40 centimeters or 16 inches. And then this telescope that I have set up on the west pier, you can see we also have these 4 permanent piers on which we can put smaller telescopes. And usually we'll put either 8-inch telescopes or a 5-inch telescope or an 11-inch telescope for visual viewing of planets or double stars or star clusters during an astronomy class lab or a public night during observing or whatever. But since we haven't been doing that over the past year, I have this 12-inch telescope with a robotically controlled mount. So 12 inches, you know how big 12 inches is, right? Let's see, a medium pizza is 12 inches and a large pizza is 16 inches, right? So compare the area of those two sizes. And so this medium size, it's really a medium-sized telescope. I mean, for an amateur astronomer, it would be a big telescope. It's kind of a medium-sized telescope for a teaching observatory like this. But it's sort of, it's always a trade-off with having a telescope that has a big mirror so it can gather a lot of light, but then it will also have a lot of magnification that will cause you to see a very narrow part of the sky. Now, sometimes you do want to see a very narrow part of the sky, but often you want to see more of the sky at once. You want a big picture. You don't want a zoom lens, you want a wide angle lens of what's going on. Is it possible to see Andromeda right now? We can take a look. It may be that Andromeda is behind the dome. So I think Andromeda is to the northwest from the view of this particular telescope. So it might be difficult. You know what, before we move on to something else, I think maybe we should try to move to Orion next. That's going to we'll have a really good view of Orion. And what we should do is switch over to the other software that takes the camera out of video mode and puts it into long exposure imaging mode. And before we do that, I'll do 2 things. We'll look at the names of the stars in the Pleiades. So let's zoom in on the Pleiades. Yeah, so I definitely see these 2 stars in the image that I had. So that's Alcyone, and then Atlas is over here on the far left. And then this one is, what is that one? That one doesn't have a common name. And then there's Merope there. Electra, I always remember Electra is over there. And then Maya is up here. It might be interesting to move the telescope a little bit to the right to see this part of the star cluster, because I think we're mostly seeing this part of the star cluster. There is some beautiful nebulosity, reflection nebulosity, which is a little bit behind the star cluster. And the reason that this nebula looks blue is because there are very fine dust grains in the galaxy that are scattering the blue light from the stars back towards us. So just like the way the sky looks blue, so sunlight passing through the atmosphere, the blue light gets scattered to your eye, and you look up at the sky and it looks bluish. You're seeing blue sunlight scattered off of molecules in the atmosphere, and the red light preferentially gets through. The blue light from the stars is scattered off of the galactic dust, and you see bluish color in these reflection nebulae. To see that, you have to take a fairly long exposure, and you have to adjust the contrast because the stars are so much brighter than the nebula. So it's a little bit challenging to get a beautiful image like this that shows both the stars and that wispy reflection nebulosity. Let me just jump back to that image. Yeah, so that's Alcyone, that's the star I don't know. And you know what, let's just nudge the telescope over a bit to the right, which would be to the west. Maybe a little bit more. And let's see what that looks like there. The stars got shifted. So that bright star right there, I believe, is Merope or Electra. Let's go a little bit further. So you see the yellow circle is where the telescope thinks it's pointed, so it's shifted over just a little bit. So let's see that. Yeah, I think that's Electra and that's Merope. So those are bright bluish stars in the Pleiades star cluster. Okay, I'll just do a very quick presentation on what's up in the sky, and then we'll look at the Orion Nebula, and then we'll look at maybe the M44, the Beehive cluster, and then we'll see if maybe Andromeda is up, and if there are any other requests, and see if there's anything else people want to look at. Is there a mechanical telescope I recommend to students or amateur stargazers? By mechanical telescope, you may mean a telescope with a motorized go-to mount. I generally recommend people get a non-motorized telescope first. For example, one that I've shown a couple of times. Let's grab this. I have this, pardon my mic noise here, I have this Newtonian, this 5-inch Newtonian telescope, which I bought with my own money for my own personal travel use and sometimes for teaching use. And I bought it from Astronomers Without Borders. And I think it's a really good starter telescope. It's very portable. It's very easy to set up. I won't do a whole tutorial with it right now. I'd like to do one outside a little bit later on. But if you are looking for a telescope to get into astronomy, my advice is always to start with a pair of binoculars for $50 to $100, right? And you don't need a mechanical telescope. You can just take a star chart outside and look with your binoculars and find the bright stars, find star clusters, find the Messier objects, look at the moon. And then when you're a little bit more advanced and you know your way around the sky a little bit, you can upgrade to an amateur telescope. And this telescope has a mirror in it, in the back there, which is 5 inches in diameter, which is very good. There's a lot of star clusters and nebulae and even a few galaxies that you'll be able to see with that size telescope. This telescope comes on a very simple mount, which is really just I don't know how well you can see that with the green screen, but very simple turntable mount. You can set it up on a table or a park bench or a car. I've set this up on a car hood many times. And you just extend the front of the telescope up. So now it's out of the frame. And you've got a really nice, easy to use point and view telescope. So there's an eyepiece on the side right there, and there's a laser finder scope on the side right there. So this is a good telescope to start with. You don't have to get this telescope. There are other good options as well. This one costs $200, and I think it's a really good value. I think it's especially a good value because you get everything you need to start doing telescope viewing astronomy, and you can even do a little bit of astrophotography on planets and the moon, putting a camera up to the eyepiece. But it's also very upgradable. So as you get more interested in astronomy, you can buy better quality eyepieces that give you higher magnification or sharper views. You can buy filters that give you a better view of a nebula or something like that. you can get a whole equatorial mount. So this this tabletop mount that this telescope ships with is great for travel, but if you wanted to get into astrophotography or more sophisticated astronomy to find things, even if you wanted to get a mechanical, automated, computer-controlled telescope mount, you could buy one for a few $100s and use this telescope with the mount. Yeah, it's an important thing to realize about amateur astronomy is that the telescope and the mount should be considered separately, right? So I don't know, what's an analogy with another hobby? What are my other hobbies where this applies? I can't think of I can't think of one. But just like, you know, if you work with bicycles or cars, or if you build computers, you know, you have all these different components, and let's say you build a computer and then you decide, I need a faster processor, or I need better memory or a better graphics card or whatever. You can replace that part. And the same is true with telescopes. You can replace the eyepiece, the finder scope, and the mount. And especially if you get into astrophotography and you want to take pictures of nebulae or clusters or whatever, your mount is going to cost a lot more than the telescope. Yeah, sorry, that was a long-winded answer to your question, but I recommend people who are sort of beyond the binoculars stage. Start with the binoculars, and even if you get beyond binoculars and you realize, oh, I want to see fainter objects, or I want to you know, have a better view of the planets or whatever, you will still use your astronomy binoculars in the hobby. And of course, you can use them for nature viewing and birding and sports and all of the things that binoculars are good for. And it'll help you sort of get a feeling for how do you find objects in the sky. You know, binoculars aren't so great for magnification, right? Because you're holding them with your hands. These are 10x magnification binoculars, and I wouldn't buy binoculars that are higher than that, because as you're looking, your hands are shaking and the image is shaking and so forth. 7x35s are also a really good option for binoculars. These are 10x50s, which I think are good. These that I have, the 2x54s, are ridiculous. I don't recommend buying them unless you know what you're getting into, because you don't get much, you don't really get any magnification at all. 2x magnification. Okay, so I'm going to quit out of this camera program. Okay, that's fine. We'll stop capture, and let's see. Exposure. Okay. I have to turn the exposure down to get it to let me stop. Stop. Okay, there we go. Okay, I'm going to close this program, and I'm going to move the telescope to the Orion Nebula. All right, so I'm going to zoom out a little bit, and there are a couple ways that I could identify it. Yeah, that's good. So I'll say telescope. And slew. All right, so now the telescope is moving over to that target. We can see it in the live camera view here. It's moving kind of down and to the left to find Orion. Orion is going to be due south at 7 o'clock tonight. And now it's a little bit west of due south because it's now 7:40. And let me just talk a little bit about what's up in the sky. It's now March, and so there's a new version of the evening sky map, which you can download from skymaps.com. So this is the sky map for beginners that I always recommend that you get once a month. You know, there's similar types of sky guides in magazines such as Astronomy Magazine or Sky and Telescope Magazine. But this one is free. You can print it out, put it on your refrigerator or by the door, and then you have a nice calendar and map for what's happening in astronomy this month. So the sky looks pretty similar to the way it did towards the end of March. So this is early March at 9 p.m. or late March at 8 p.m. So it's now getting close to 8 p.m. So this is what the sky is going to look like in about an hour and a half from now. And the idea of this circular sky map is that if you were lying back on the ground with your feet pointed south and your head pointed north and the eastern horizon to your left and the western horizon to your right, this is the kind of fisheye view that you would have around the sky. Another way to use the sky map is to just hold it with the horizon at the bottom of whichever direction you're facing. So if you're facing south, you would hold it with the paper oriented so south is written at the bottom. And if you're facing north, you turn it 180 degrees. And if you're facing west, you turn it 90 degrees. And then it's going to match up fairly well with the stars. There are a lot of good smartphone apps also that do something similar. Maybe I'll make a video at some point reviewing some of these star finder apps where you just hold up your phone. The one that I've used mainly is Starwalk, and there's a Starwalk 2 app. So I've used that a couple of times to orient myself in the night sky. Anyway, in terms of the constellations and the bright stars that I would point out, we were just looking over here in the direction of Taurus. And then Uranus is not visible to the naked eye, but it's sort of over here in the constellation of Aries. Andromeda would be over here in the northwest. So there's the Andromeda constellation, and there's the Andromeda galaxy, sort of right next to her knee. So I suspect it's too low in the northwest now for us to view with the 12-inch telescope. We'd have to go up to the parking lot of LFOP if we wanted to have a clear view of the northwest horizon. We have all these bright stars in the direction of the Milky Way, the winter hexagon. So Sirius, the brightest star in the sky, and then up to Procyon, Pollux and Castor, the two bright stars in Gemini. Capella, the goat star, which is not quite overhead anymore. It's a little bit west of overhead at this time. Down to Aldebaran, and Mars is, you can see how much Mars is moving relative to the Pleiades over the course of the month of March. So right now Mars is right next to the Pleiades, but you can see there are a couple of dates like Moon near Mars right here on March 19th. And then Mars is basically going to move very slowly along the ecliptic through the zodiac, getting fainter and fainter, and then it's going to line up with the sun, and then it will appear in the morning sky, very dim. And Mars is going to be dim and not very interesting for about a year and a half now, until we get to the next opposition, which will be in 2022, sort of December of 2022. Mars will be bright again. We have Leo coming up, and actually I'm hoping to take a picture of Leo in a couple of hours out on the observing deck. The asteroid I'm interested in is the asteroid Vesta, which is right here at the back of Leo right now. I could actually show you where that is in Stellarium, right? So Stellarium, a computer simulator like this knows where all of the minor planets and asteroids and planets are. And so there is the asteroid Vesta. So here's the constellation of Leo filling up the screen, right? And Leo is easy to find because it's a fairly bright constellation. You've got the bright star Regulus here, makes this backwards question mark at the front of Leo, and then this sort of right triangle at the back of Leo. And it's low in the east at this moment, at this instant. Kind of low in the east, but in an hour or 2 hours, if we sort of jump ahead, let's see, jump ahead, there it is at 9 o'clock, there it is at 10 o'clock, it's going to be higher in the sky, and that's when I'll try to take a picture of Vesta. So there is the asteroid Vesta. Now, the thing about asteroids is they are much too small to see any detail when you look at them through a ground-based telescope. So they just look like stars, just points of light. That word asteroid means star-like. But the thing about the asteroids is they move like the planets in that they move relative to the stars. So if I look at where Vesta is tomorrow night, and then the next night, and then the next night, and the next night, you see it's moving. There's the path of its orbit. It's moving up and to the right through the constellation of Leo. So I did a project when I was in college, actually, to track the asteroid Vesta through our campus telescope and then try and determine the orbital path of Vesta. And that was kind of a fun project. Vesta is also a very interesting asteroid. It's one of the brightest asteroids because it's so reflective. Whereas most of the asteroids are very dark. They're like hunks of charcoal in space. The moon is very dark. The moon only reflects 10% of the light that hits it. But Vesta is quite reflective. And we had a spacecraft orbiting Vesta until a couple of years ago that took some very sharp images of the surface of Vesta and analyzed the surface composition. And we discovered there was a big crater on the southern part of the asteroid Vesta. And it turns out that there was an impact that knocked a lot of debris off of Vesta. And about 20% of the meteorites that hit the Earth come from the asteroid Vesta. And I've got one right here. I've actually got a piece of Vesta. So this is a meteorite which I purchased off of eBay from a meteorite. Let's see if I can get the focus on it. This is a meteorite which I purchased off of eBay from a meteorite seller. And there's a whole card of authenticity that goes along with it. But this is, you can see, oh, that's actually reversed, so you can't actually read it. But NWA 12227, that's the actual asteroid or meteorite find from Algeria. And I believe this was in 2016 or 2017 that this particular asteroid was found. But you can see how reflective it is, and there's little bits of material in there. So this is breccia from the mantle of Vesta, and it was knocked off of the asteroid Vesta millions, maybe even billions of years ago, and then orbited around in the solar system, and then fell to the Earth, again, millions, probably not billions, but maybe millions, maybe thousands of years ago, it fell to the Earth, and then a meteorite hunter picked it up and cut it into pieces and sold it to people like me. Anyway, so I'm excited to take some pictures of Vesta. We'll see how it goes. It should be bright enough that I can see it even with my little $200 digital camera. So we'll see how that goes. Okay. I don't know if there's anything else I want to show on the star map. On clear nights, we can look at some of these objects in more detail, and I think I'm going to go look at the Orion Nebula here in just a minute. But there's some galaxies. There's some really nice galaxies coming up over here in the direction of Leo and Virgo. So those are great targets. Not much happening on the calendar over here, although March 20th is the spring equinox, right? So when the sun rises due east, and we have 12 hours of daytime and 12 hours of nighttime, the first day of spring. So this year it's happening on the 20th. It's happening at 9:40 Universal Time, and Eastern Time is 5 hours behind UT. So that would be 4:40 a.m. It is the exact moment of the equinox when the sun exactly crosses the equator. And so that's when we're going to have spring. So then the full moon, there's going to be a first quarter moon right after that and a full moon on the 28th of March. And the convention is that Easter is always the first Sunday after the full moon, after the spring equinox. So whatever Sunday it is after the 28th is the date of Easter. So you probably already have that on your calendar, but if you don't, it's going to be the Sunday after the 28th. That's the astronomical technique for finding out what the date of Easter is going to be. Okay, I have a question. Chris asks, what brand model telescope is the 5-inch I was showing? This is it's made by a company called Cinta, which is sold under the brands of Celestron, Orion, and what's the other company? Skywatcher, I think. But this particular version is branded under Astronomers Without Borders. So the brand is right there. Yeah, I know it's reversed, but Astronomers Without Borders, which is a nonprofit organization. One of the founders is my friend Mike Simmons. And they have a deal with Cintra to sell this telescope for $200. And it only costs a little more than $100 to make it. So $100 goes to astronomy education and outreach that's done by Astronomers Without Borders. And they do international, Mike does a lot of astronomy sort of people-to-people connections with astronomers in Iran and the Middle East, but then they also do astronomy education in Africa and Asia and South America, all over the world. So you're not only getting a great telescope, but if you're interested in astronomy education and outreach, you're supporting a good organization, Astronomers Without Borders. So it's called the One Sky Telescope. I can maybe type it in the chat. And if you look up Astronomers Without Borders online, you can find the page to order it. And it's a really good deal. You're getting a really good telescope for $200. There are other good telescopes for $200. Another one that I recommend that I have is any of the Meade infinity refractors. So if you prefer to have a refractor rather than a reflector, I recommend the Meade infinity refractors. I have a 90mm infinity that I paid $200 for, and it was a good deal. It came with the telescope, a tripod, several eyepieces, everything you need to get started. And it's not one of these wobbly, cheap telescopes. I think it's hard to get a beginner's telescope for less than $100. There are some okay options for $100. And I think $200 is kind of a sweet spot if you're serious about getting into astronomy. Of course, like I said, always start with the binoculars. You can get good astronomy binoculars for $30. These are from Orion. Yeah, there's the Orion logo right there. These are from Orion, and they've got a coating to make it a little bit easier to see stars and when the sky, under dark skies. I think I paid about $100 for these, or maybe $120 for these. So I recommend spending $50 to $100 on good binoculars to get started. Okay, let's go look at Orion. Let's go look at the Orion Nebula, and then I think maybe we'll stop for tonight. So I need to go back to the telescope control. And I need to launch the live stacking controller here. All right. And let's see if there's a nebula there. And I need to get rid of this pop-up. All right, there we go. And I think I need to turn on the cooling. Okay. That's fine. I don't need a 30-second exposure to start with. Let's start with a 10-second exposure. Hey, there it is, the Orion Nebula. Let's nudge the telescope a little bit to the east. Beautiful. One of my favorite objects to look at through a telescope in the winter. And we can make it look even better here in a second. Oops, I moved the telescope the wrong way, the other way. It's important, to remember this software I'm using to control the telescope is a simulation of the sky. And then when I switch over to this window, this is a live image from the camera, which is on the back of the telescope right now. So if I go back to the live camera showing a view of the observing deck, there's my SLR camera on a tripod over on the left, and there's the 12-inch telescope, and you can just sort of see there's kind of a gray cylinder at the back of the telescope, and that is the CMOS camera that we're reading from live right now. There's a little control computer right next to the telescope, which is controlling the mount in the camera right now. Okay, so let's start stacking images. It already looks pretty good. Now there's a little bit of tracking error. Do you see how the stars are a little bit elongated left to right? And we could work on improving that, or we could, let's actually go with like a 5-second and then lower resolution. And then I think I'm still learning how to use this. Actually, let's turn on the ProTrack. Okay, and that will help a little bit. Okay, so let's start the stack. Okay. Okay. And then I'm going to adjust the brightness and contrast a little bit just so we get a slightly better view. Live view of the Orion Nebula from a medium-sized telescope in the city from the top of a hill on the Yale's campus in New Haven, Connecticut. All right, and as this image kind of improves, so the magic of this software is that I'm adjusting the brightness now, so that's why it's looking a little different. The magic of this software is that it's continually taking an image and then adding it to the last image and taking another image and adding it. And so as time passes, you're getting a better and better image of the faint object that you're looking at. Now, we can really see a lot in this image. You can see the nebula really well. You can see the 4 stars in the center of the nebula really well. So what's going on here, nebula is a word that means cloudy. So anything that looks cloudy in the sky is a nebula. But specifically what's going on is that this is a star formation region. And we're seeing a cloud of ionized hydrogen gas. Right? Most of the universe is hydrogen. And most of the gas between the stars is hydrogen. And most of the stars themselves are hydrogen. Right? The simplest element on the periodic table, 1 proton, 1 electron. So ultraviolet light from these young, massive, luminous stars here in the center. This is a star which is known as Theta Orionis. And it's probably 30 or 40 times the mass of the sun, and probably 5 or 6 times the temperature, the surface temperature of the sun, and maybe 30 or 40 times the luminosity of the sun. I'm talking about the brightest one right there, and there's kind of a multiple star system there in the middle. So that means that it puts out a lot of ultraviolet radiation, and that UV will ionize the hydrogen nearby and make it fluoresce and make it glow all of the colors associated with hydrogen gas, primarily red, but there's also some blue color and some green color and so forth. So that's what's going on. Now, where did these stars come from? Well, they formed recently from the gas that was in this giant cloud on the inside of the spiral arm in the direction of the constellation of Orion. And you can kind of see some evidence of that denser, darker gas. You can see there's what we call a dark nebula. So a little bit of a dark cloud right there in silhouette against the glowing gas. And there's a ridge of dark material right here. Really, the Orion Nebula is just kind of a lit cavity on the front side of a much bigger, huge, denser cloud of molecular gas, which is in the process of forming stars. And if you zoom in with radio telescopes and infrared telescopes, you can look through the dust and see the young, massive protostars that are forming just behind the Orion Nebula. So this is star birth. This is how stars are made, right here in front of our eyes. And in fact, all of these are relatively young stars that have formed in the last few million years from the gas in this molecular cloud. So the Orion Nebula is very beautiful, just it has that sort of filamentary, fractal, clumpy structure, you know, that you see in nature a lot that looks so beautiful. I'm trying to adjust the background a little bit. So the sky, one of the things we can do, even though we do have a lot of light pollution in New Haven, we can kind of subtract off the light from the sky and just highlight the, there we go, that's looking really good. And just highlight the light coming from the star, the galaxy, or the nebula, whatever we're particularly interested in. And sometimes actually we use filters to improve that as well. There are filters we can use that will block some of the city lights that's reflecting down from the sky, and we can get a better view. That's really good for looking at really faint objects like galaxies. Anyway, so a lot of these stars are relatively young. And there's more than one of these nebulae kind of in that direction of Orion and Taurus and Gemini and Canis Major, the big dog, right, where the star Sirius is. And this is the brightest one. It's the closest. This is the closest star-forming region to us. But there are other beautiful examples like the Rosette Nebula and the Cone Nebula in that Milky Way plane. All right. Well, I have been going on for a while, and it's kind of fun to sort of chat and goof off and get on tangents when the sky is nice and clear and we can just hang out around the telescope and take pretty pictures. I'm going to save this image and I'll post it in the chat, not in the chat, in the video description. So if you'd like to see this image up close, you can download it from there. And I'll also post the image of Uranus and the moons before. So let me go ahead and do that. All right, so I just saved that image. It's still reading out. I'll go ahead and stop that. And I will sign off here. So thanks to everyone for tuning in for the live stream. It's nice that it was clear tonight so we could look at some live images of Mars and Uranus and Orion and some of the Pleiades stars and so forth. So I'll be back next Tuesday, clear or cloudy. We actually have a guest speaker coming up, not next week, but the next. We have a Richard Grosch who's going to come and talk about his research on AGN. So I'll post an announcement about that on the Leitner Observatory website. So Leitner Observatory, our website is Leitner, leitnerobservatory.yale.edu. My email address, if you have any questions for me, my email address is michaelfaison, so Faison at yale.edu, michael.faison at yale.edu. I'm going to be working here for a few more hours looking at Vesta and looking at some other asteroids for a research project. So nice to see everyone. For those of you live, thanks for coming and asking questions. I really appreciate it. And hope to see you next time.